this video, I'm going to show you how to solve the following quadratic inequalities and graph the solution on a number line. So I'm going to start with my first example, x squared minus 8x plus 12. It's a quadratic equation, or quadratic expression. Greater or equal to 0 makes it a quadratic inequality. Step 1. I'm going to solve where this quadratic expression is equal to 0. I'm going to solve that equation. We call these points the critical points. Now we can solve this in a couple of different ways. We can use the quadratic formula, because it's a quadratic equation. We could complete the square, we learned that. Or we could solve by factoring. And since this does factor, and we'll go ahead and do this. If you remember, this is the first, so I'm going to make that the first x. This is the 12 is the last, so two factors of 12 that add up to negative 8. I'm going to say 6 and 2, and if they're both negative, that does make negative 8. So I have two solutions, one where x equals 6, or where x minus 2 equals 0, and x equals 2. So that's what is going to be my first step. Second step. I'm going to plot these 2 points on the number line. So I'm going to draw a number line. And here we have 0, so we'll label 2. And finally 6. So there is my number line. And for step 3, I'm going to ask myself the following question, because what we did is we found 2 and 6, the places where they're equal to 0. So that takes care of the greater than or equal to. But now we want to figure out where this quadratic expression on the left here is greater than 0, which leads us into step 3. So what I'm going to do with step 3 is I'm going to take this expression on the left and I'm going to set it equal to y. And I realize, and I'm looking for where is that y bigger or equal to 0. Or just bigger than 0, because I found out when it was equal to 0. Now I realize that this equation on the right in step 3 in red is a parabola. That's a graph of a parabola. It's a parabola that opens upward because the a is 1, the a is positive, so it opens upward. And the intercepts, when y is 0, by the way, is the x-intercepts, are the exact solutions I found in step 1. So what I'm going to do is I'm going to graph this parabola. I'll do it in red, and I'm going to make it upward, and I'm going to show, so I'm thinking of this as a xy plane now, and I'm going to show the x-intercepts to be, or I'm going to place the x-intercepts at that 2 and that 6. I don't even care how wide or narrow that parabola is. I just care about those intercepts. So I'm just going to draw any upward parabola that goes through 2 and 6. And then I'm going to ask myself the following question. Because this, we really want to know where this is greater or equal to 0. Right? That was our original question. So I'm going to ask myself, where is y greater or equal to 0? And if you look here at this graph, if I look at 7, for instance, the value at x equals 7 is positive. That's a positive y value. X equals 8, it's also positive. In fact, anything bigger than 6, x is positive. Okay. What about stuff in between here? Between 2 and 6, like 4. All these values, let's look at x equals 4, that's a negative y. All these values inside between the 2 and 6 are negative, which are not bigger or equal to 0. Bigger or equal to 0 means positive values. So let's look at things that are smaller than 2. At 1, for instance, 1 again is positive, isn't it? So everything, in fact, even 0, because this goes on and on forever, all values this way are 0. We can get rid of that 7. And what's in red just on the x-intercept if I take away my parabola for a second, what's in red right there is the solution of the quadratic equation on the number line. Let me bring back that parabola because you really don't need to erase it. So the solution is x is, if you notice here, this means less than or equal to 2, or x is bigger or equal to 6. It's weird. See, one of these, right, it stays the same, but the other one flips. And if you remember when we had linear, if a lot of times they would flip if you multiply or divide by a negative. Well, here we're not multiplying or dividing, but one of them does flip, right? One of them represents that negative. Okay, so that is the answer. This is the graph on the number line. Although sometimes they will ask for the value in interval notation. So we have to talk about what interval notation is. So the interval notation is another notation for writing the solution set. And what you do is you start here, you go left to right on your number line. So I'm going to start at negative infinity. So you write negative infinity. And the comma means 2, and you stop at 2. And if 2 is included when it's greater than or equal to, it's going to be a bracket. So that's going to be a bracket there. And it's going to be a parentheses if it's not included. So for instance, if it's a greater than sign, without being a greater than or equal to, the 2 would have been a parentheses. On the left here, you never hit negative infinity. So that's why on the left, they do it a parentheses. For the word or, they make that a union. That's a U for the or. And then we do a skip, and we start again at 6, 2, and you go out to a very large number, to infinity. Again, the 6 is included, so it's a bracket, and the infinity is not included, so it's a parentheses. So if they ask for the answer, by the way, this is called set notation, the first one. The interval notation is the second one. So if they ask for the answer in interval notation, you write the second one, and if the answer is in set notation, you write the first one. Okay, that is that one. So let's do the same thing for our second problem. So step 1, you solve the quadratic equation, x squared minus 3x minus 18 equals 0. Again, this factors, but if it doesn't, I would use the quadratic formula. And now I'm looking for 2 factors of 18 that subtract the 3, so I get 6 and 3. And we want the 6 to be negative to make that negative 3. So the 2 values of this are x equals 6 or x equals 3. Step 2, plot these on the number line. So to plot these on the number line, oops, I made a mistake. That's negative 3, isn't it? X plus 3 equals 0, or x equals negative 3. So I'm going to go 0 here. Here's my negative 3. And here is my 6. Now, the difference is 3 and 6 are not included because it is a plain less than. The one that we had earlier was a less than or equal to. So that means that those solutions were included. So what I'm going to do is I'm going to do an open circle for those. Then what I'm going to do is I'm going to figure out my shading. Step 3. To figure out my shading, I'm going to take this left expression and set it equal to y. Again, that's a parabola that opens upward, but now it has the x-intercepts of 3 and negative 3. So there's my parabola. Now I'm looking for when they are less than 0. I'm finding where, right, less than 0. Where is y less than 0? So again, if I check 7, I realize that's positive, doesn't work. If I check anything in between, like a 3, that is a negative value. Again, if I pretend this is my y, at 3, you can see the y is negative. So now my solution is going to be in the inside. So let's go ahead and do that. The solution is in the inside. And that is the solution on the number line. Just that purple there. So the answer to this then would be x is in between. Do you remember we did a compound inequality before? -3 and 6. That would be the answer in set notation. If you're going to do this in interval notation, there's no infinities included. So all you got to do is you got to start at -3, the comma means 2, and you get to 6. But since these are not included, we don't do brackets. We just do parentheses. It looks like an ordered pair, but it is also the interval notation for this solution. Again, this means starts at -3 and goes to 6. If these were solid, if it was a less than or equal to, then it would be brackets instead of parentheses. So that is how you solve the second quadratic inequality.